This is a plugin I made for Sublime Text. It's a graphical debugger which currently supports only Python, but it's implemented with the idea of supporting any possible language. It's hosted on Package Control, which is the default package manager for Sublime Text. You can see that it's a trending plugin right now, and it's got about 12,000 downloads in 11 months. This is how it looks. So let's go see it in action. I have made a simple script for testing the debugger. The first thing you do is open this right panel, which will be filled with information about our program once the debugging process starts running. When we run the debug command, the variables panel fills with information about the variables defined both in the global scope and the local scope. You can see that the line that we are currently stepped in is highlighted on the left panel. On the bottom we have a text field for entering commands. The first thing I'm going to do is to set a breakpoint at line 15, which is inherited from the Python debugger. Once I set a breakpoint, a yellow circle appears at the side of the line number, indicating that there's an active breakpoint there. You can get help on all the commands available on the debugger by typing the h command. Most of these commands are inherited from the Python debugger, and some of them have been enhanced. If I hit the C command, it tells the debugger to continue with the execution of the program. You can see that now it stops at line 15, which is where I set the breakpoint. Once it stops there, it shows new variables that have been defined. You can see that now the functions integrate and can appear on the variables panel, and also the add operator that we imported on the first line. You can also see that number 15 appears in the breakpoints panel, indicating that there's a breakpoint there. If I hit the S command, it steps one line. Now the new variable list1 appears in both the global scope and the local scope. If I hit enter, the previous command is repeated, and we step inside the integrate function. Once we get inside, we can see the value of the mylist argument appear on the local scope of the function. If we hit enter again, we step on the scan function which was called. If I enter the O command, I can go to the outer frame, and if I hit the I command, I can get into the inner frame. I can keep stepping through the code and see how variables are being modified real time. The expression panel allows us to evaluate arbitrary Python expressions in the current context that we are tapped in. For example, currently there is a variable called integral defined on the local scope, which happens to be a list. If I get the second element from this list, I can see that it's a 2. I can get the third element from that list and multiply it by 5 and see the result of that expression. In this case, the third element is 6, so the result happens to be 30. You can evaluate any arbitrary Python expression in this field. You can evaluate multiple Python expressions and keep track of them real time. If I enter several of them and step through the code, their values will be modified real time. All these commands I enter are well documented on the help menu. I will now give you a brief outlook of how this works under the hood. The first problem that has to be solved is that the language in which the text editor that you are using is implemented in will be different from the language of the code that you are trying to debug. For that reason, we need two processes, one running in each different language. Process number one will be a process running with the language of the text editor that you are using. We will call that the front-end process. Process number two will be running in the language of the code that you are trying to debug. We will call that process the back-end process. Both processes will need to communicate with each other. In order to achieve that, we will use TCP, which stands for Transfer Control Protocol. When we make two processes communicate with each other, that's usually called Remote Procedure Call, or RPC, because one process calls procedures which are on a different process, hence a remote process. Then we will find a new problem. The problem is that each of these processes have to take care of two different tasks each. They have to communicate with each other and also perform the task that they are supposed to do. In the case of the front-end, receive commands from the user and display information to the user. In the case of the backend, it has to run the code and retrieve information. These two tasks that each process has to do have to be performed simultaneously. For example, we cannot block the user from using the text editor if we are waiting for the user to enter a command. For that reason, each of the processes will have to run two threads each. One thread will be in charge of communicating with the thread of the other process, and the other thread will be in charge of performing the task which is particular to that process. The threads in charge of communication are usually called client and server, depending on whether they are on the front end or the back end.